Hello learners, welcome to this session. This session is on software development of information systems. I am Professor V.V. Subrahmanyam, Director, School of Computer Information Sciences, Indira Gandhi National Open University, New Delhi. The process of developing good software is usually not as simple as sitting down and writing some code. True, sometimes a programmer can quickly write a short program to solve a need, but most of the time the creation of software is a resource intensive process that involves several different groups of people in an organization. In the following presentation, we are going to review several different methodologies for software development of a software product or an information system. In the earlier session, we had talked about the information system and its applications. So, in this particular session, let us concentrate on how these information systems are developed. So, there is one important aspect we have to study, that is the software development life cycle. In short, we can call it as SDLC, software development life cycle. So, software development life cycle also referred to as application development life cycle. It is a framework that defines the steps involved in the development of software at each phase. So, there are several phases we can talk about in the software development life cycle, and it consists of several phases, and we can talk about each and every phase and what exactly is the functionality each phase does. So, it covers the detailed plan for building, deploying and maintaining the software. SDLC defines the complete cycle of development, that is all the tasks involved in planning, creating, testing and deploying a software product or an information system. SDLC is a process which defines the various stages involved in the development of software for delivering a high quality product. SDLC stages cover the complete life cycle of a software, that is right from the inception to maintenance of the product. Adhering to the SDLC phase wise process, it leads to the development of the software in a systematic and disciplined manner. The SDLC is not a methodology per se, but rather a description of the phases in the life cycle of a software application. So, you can see here there are several stages or phases you can say. The first phase is requirements analysis, design, development, and in the development you can talk about the coding part, testing, deployment and then maintenance. So, let us study each and every phase. First phase is the preliminary analysis, or else you can call that one as the requirements analysis. So, in this phase, a review is done for the request made by the client. Is creating a solution possible for the requirement that he has specified? What alternatives exist? What is currently being done about it? Is this project a good fit for the organization? A key part of this step is a feasibility analysis, which includes an analysis of the technical feasibility. Is it possible to create this? And then the economic feasibility. Can we afford to do this? The legal feasibility. Are we allowed to do this? And this step is important in determining if the project should even get started or not. So, this feasibility analysis phase is a complicated phase, or else you can call it as a complicated step, wherein which it determines whether the project needs to take off or not. So, system analysis phase is the phase one or more system analysts work with different stakeholder groups to determine the specific requirements of the system. Remember, no programming is done in this particular phase. Instead, procedures are documented, key players are interviewed, and data requirements are developed in order to get an overall picture of exactly what the system is supposed to do. The result of this particular phase is a system requirements document. So, this particular document, system requirements document, is the input for the system design, which is called as the second phase of the system development, software development life cycle. So, in this phase, a designer takes the system requirements document created in the earlier phase and develops the specific technical details required for the system. It is in this phase that the business requirements are translated into specific technical requirements. The design for the user interface, database design, data inputs, outputs, reports are screened and developed here. The result of this particular phase is a system design document. This document will have everything a programmer will need to actually create the system. The next phase after the analysis is the coding phase. The code finally gets written in the programming phase. Using the system design document as a guide, a programmer develops the programs, or else a team can develop the software. The result of this phase is an initial working software that meets the requirements laid out in the system analysis phase and the design developed in the system design phase. The next phase we can talk about is the testing phase. In the testing phase, the software developed in the previous phase is put through a series of structured tests. The first is the unit test, which tests individual parts of the code for errors or bugs. Next in the system test, where the different components of the system are tested to ensure that they work together properly. Finally, the user acceptance test allows those that will be using the software to test the system to ensure that it meets their required standards. Any bugs, errors or problems found during testing are addressed and then tested once again. The next phase to the testing is the implementation phase. Once the new system is developed and tested, it has to be implemented in the organization, and this phase includes training the users, providing documentation and conversion from any previous system to the new system. Implementation can take many forms depending on the system, type of the system, the number and type of users, and how urgent it is that the system become operational. After that, the maintenance phase comes into picture. This is the final phase which takes place once the implementation phase is complete. In this phase, the system has a structured support process in place, reported bugs are fixed, and requests for new features are evaluated and implemented. System updates and backups are performed on a regular basis. So, this SDLC methodology is sometimes referred to a prominent methodology called as the waterfall model to represent how each step is a separate part of the process, and only when one step is completed we can go to another step to start with. After each step, an organization must decide whether to move on to the next step or whether to stop. This methodology has been criticized for being quite rigid. Why? Because there is no flexibility over here, and every time as we are going ahead, the previous step needs to be frozen. For example, changes to the requirements are not allowed once the process has begun. No software is available until after the programming phase. So, there will not be any kind of software availability until we go to the programming phase. Again, SDLC was developed for large and structured projects, and the projects using SDLC can sometimes take months or years together. Because of its inflexibility and the availability of new programming techniques and tools, many other software development methodologies have been developed. Many of these retain some of the underlying concepts of SDLC, but are not as rigid as waterfall model. So, here you can see the waterfall model, the analysis, then comes the requirement specifications, the design phase, development phase, testing and integration, and implementation and deployment. So, each and every phase, all the 6 phases, it goes one step after the another. Let us see the advantages of waterfall model. Due to the logical structure of the model, conceptual errors can often be avoided. It is a very rigid model, and here you can avoid the conceptual errors. The model leads to extensive technical documentation, which is a relief for new programmers and developers, and is also useful in the test phase. Project progress can be monitored using the milestones. The total cost can be estimated with relative accuracy if there are no conflicts. However, it suffers with certain disadvantages also. Let us see the disadvantages of this waterfall model. Conflicts, bugs, and program errors sometimes lead to rising costs and a considerable amount of more time. The same applies if the clients are not satisfied also. The specifications that are initially made are often difficult for clients to understand because they are more abstract than what the software is supposed to do. Especially in outsourced projects, this can be a decisive disadvantage since the releasing date must be postponed and the marketplace may have changed during this time. So, delivery of the software takes longer because departments do not work simultaneously and each phase can only begin when the previous phase is completed. So, these were the disadvantages of the waterfall model, and let us see about the prototype model. This is the second model wherein which it has certain advantages over the waterfall model. Let us see the prototype model. The prototype model is a model in which a prototype is developed prior to the actual software. So, there is an intermediate stage involved here in this particular model. So, prototype models have limited functional capabilities and inefficient performance when compared to the actual software. Dummy functions are used to create prototypes. This is valuable mechanism for understanding the customer's needs. Software prototypes are built prior to the actual software to get valuable feedback from the customer. Feedbacks are implemented and the prototype is again reviewed by the customer for any certain changes. This process goes on until the model is accepted by the customer. You can see over here the prototype model. Once the requirements are gathered, then the design phase starts. A prototype is developed. Customers evaluate that prototype, refine the prototype. Once again, if at all it is been refined, the design phase starts and there will be a kind of loop over here. Once it is finalized, it will roll to the final product. Once the requirement gathering is done, the quick design is created and the prototype which is presented to the customer for evaluation is built. Customer feedback and the refined requirement is used to modify the prototype and is again presented to the customer for evaluation. Once the customer approves the prototype, it is used as a requirement for building the actual software. The actual software is built using the waterfall model approach. So, what are the advantages of prototype model? As you can see, there is an intermediate step called as the prototype prototype was being developed. Prototype model reduces the cost and time of development as the defects are found much earlier. Missing feature or functionality or any change in the requirement can be identified in the evaluation phase and can be implemented in the refined prototype. Involvement of a customer from the initial stage reduces any confusion in the requirement or understanding of any functionality. Coming to the disadvantages, since the customer is involved in every phase, the customer can change the requirement of the end product, which increases the complexity of the scope and may increase the delivery time of the product also. Then comes the third model called as the spiral model. The spiral model includes iterative and prototype approach. So, this is a kind of mixed model wherein which the iteration is possible and then the prototype whatever that we had talked about in the previous slides is also included. Spiral model phases are followed in the iterations. The loops in the model represent the phase of the SDLC process, that is, the innermost loop is of requirements gathering and analysis, which follows the planning, risk analysis, development and evaluation. Next loop is designing, followed by implementation and then testing. You can see over here the spiral model. What are the advantages of spiral model? As you can see, it is a kind of mixed model. Risk analysis is done extensively using the prototype models. Any enhancement or change in the functionality can be done in the next iteration. Coming to its disadvantages, the spiral model is best suited for large projects only. The cost can be high as it might take a large number of iterations, which can lead to high time to reach the final product. There is another technique called as the rapid application development. In short, we can call it as a RAD, rapid application development. It is a software development methodology that focuses on quickly building a working model of the software, getting feedback from users and then using that particular feedback to update the working model. After several iterations and development, a final version is developed and implemented. So, you can see over here, it is cut short with only 4 stages: requirements planning, user design, construction and cutover. So, instead of 6 to 7 phases in the software development life cycle or else the waterfall model, it is being cut short with only 4 particular stages. RAD methodology is much more compressed than SDLC. Many of the software development life cycle steps are combined and the focus is on user participation and iteration. This methodology is much better suited for smaller projects than SDLC and has the added on advantage of giving users the ability to provide feedback throughout the process. SDLC requires more documentation and attention to detail and is well suited to large resource intensive projects, whereas this RAD model is best suited for the smaller projects. RAD makes more sense for smaller projects that are less resource intensive and need to be developed quickly. Then there is another methodology which is very much popular from 2001 onwards. This methodology is called as the agile methodology. These agile methodologies are a group of methodologies that utilize incremental changes with a focus on quality and attention to detail. Each increment is released in a specified period of time called a time box, creating a regular release schedule with very specific objectives. While considered a separate methodology from RAD, they share some of the same principles, that is the iterative development, user interaction and ability to change. The goal of the agile methodologies is to provide the flexibility of an iterative approach while ensuring a quality product. Here you can see the agile methodology: define, build and release, and this particular loop always contains, and we can call that particular thing as the time box, and the sprints will be developed and are being released. This methodology nowadays they are used in the mobile application development or a simple web based projects also. So, they are including the services, rolling out and once again taking the new requirements and then preparing a simple web service and once again they are releasing the product. Likewise, define, build and release are the primary aspects of the agile methodology. So, coming to the characteristics of the agile methodologies, they are small cross functional teams that include development team members and users, daily status meetings to discuss the current state of the project, short time frame increments for each change to be completed, and at the end of each iteration a working project is completed to demonstrate to the stakeholders. So, we had studied several types of models in order to develop the information systems. We had started with software development life cycle, which may be called as waterfall model, and then we had seen the prototype model, the spiral model, the agile methodologies and other models. Before concluding this particular session, software development life cycle is the process of developing information systems through analysis, planning, design, implementation, integration, maintenance and testing of software applications. SDLC is also known as Information Systems Development or Application Development Life Cycle. The development of quality software involves the usage of structured approach towards the design and development of the end product. In a nutshell, the success of SDLC process for building a successful software system rests on the following factors. One is its scope restriction, second is progressive enhancement, third is predefined structure, fourth is incremental planning at each of the stages. So, if these steps can be followed in entirety, most of the risks that evolved in the software development life cycle can be mitigated. Hope you had understood how an information system is built using various models. There is no one fixed model like suited for each and every information systems. It adapts right from the traditional to the latest advanced models. So, with this I will conclude this particular session. Hope you had understood the underlying concepts of this particular software development life cycle, and in the next session we will study what are the tools and technologies those are helpful in order to develop the information systems. With this I will conclude this particular session and we will meet in the next session like what are the various tools and technologies those can be used in the development of the software of the development of the information system. Thank you and happy learning.
Sir, in my conclusion question.
Firdaus. Before the conclusion of this particular session, sorry.
Just like with this I concluded, I hope.
Right. Hope you had understood this particular underlying concepts, whatever we had concentrated upon in this particular session, and in the next session let us talk on the tools and technologies those are used in the software development of a information system. Thank you and happy learning.